Have you ever wondered how some of the most powerful AI on the planet can write a beautiful poem 1 minute and then completely fail at a simple math problem the next? Well, it's a super interesting paradox. And it turns out the answer is surprisingly simple. We were just asking the question the wrong way. Let's get into it. So we all know that these large language models, the AI behind tools like ChatGPT, are incredibly powerful. I mean, they can write code, compose music, generate all kinds of amazing text. But for the longest time, they've had this really weird blind spot, this baffling inability to solve problems that require more than one step. And this right here is the puzzle that had researchers scratching their heads. How can an AI that seems so incredibly smart totally bomb a problem a middle schooler could figure out? It's a really fascinating question, right? For years, if you gave an AI a multi-step problem, you'd often get, well, a very confident but also very wrong answer. It was a huge roadblock. The models were amazing at spotting patterns, but they really struggled to actually reason their way to a solution. Okay, check this out. It's a perfect example. On the left, you ask the question in a standard way, and the AI just blurts out a wrong number. It's basically guessing. But look at the right. The approach is totally different. The AI is prompted to think it through step by step, and that one simple change unlocks the correct answer. This is the whole key right here. So how do you get from that wrong answer to the right one? Well, it turns out you don't need to rebuild the AI or do any crazy re-engineering. You just need to teach it to think a little more like, well, like us. And this brilliant idea has a name. It's called chain of thought prompting. Honestly, just think back to math class when your teacher would always say, show your work. That is exactly what this is. Instead of just asking for the final answer, you tell the AI to write out its entire reasoning process first. And the process itself is surprisingly simple. You just start by showing the AI a few examples where you've already laid out the logic step by step. Then, when you give it a new problem, it sees the pattern and generates its own chain of thought, reasoning its way to the final, correct answer. So, did it work? Oh, yeah. And the results weren't just a small improvement. It was a total game changer, a massive shift in the AI's performance. Okay, let's put some numbers on this. On a really tough math benchmark test for AI, Google's gigantic Palm model, just using a standard prompt, only got 18% right, which is not great. Even a specialized, fine-tuned version of GPT-3 only got up to 55%, and that was considered state-of-the-art. And now, get ready for the big reveal. Using chain of thought prompting, that exact same Palm model with zero extra training jumped from 18% all the way up to 57% accuracy. It didn't just get better, it actually beat the specially trained model. In the AI world, this was a massive deal. Now, here's the crucial part. This isn't a trick you can teach just any AI. The researchers discovered that chain of thought reasoning only seems to work on really big models. We're talking around 100 billion parameters or more. It's what they call an emergent ability, a complex skill that just sort of appears once a model gets powerful enough. But the real magic of this technique is that it's not just some trick for crunching numbers. It actually unlocks a much broader, more useful kind of reasoning. This same method also unlocks common sense reasoning. So when it's asked if a famous soccer player caught a pass in the NFC Championship, the AI doesn't just guess. It walks through the logic. Okay, this guy is a soccer player. The NFC is American football. Those are different things. And so it correctly says no. It's actually reasoning about how the world works. And it can even handle totally abstract, symbolic stuff. Here, it's asked to take the last letters of Lady Gaga and stick them together. Look at the steps. It finds the last letter of each word, and then it performs the right operation. This is a kind of symbolic thinking that used to be incredibly difficult for these models. So this all seems pretty incredible, right? But it does raise a question. What part of this chain of thought is actually doing all the work? Is there some kind of secret ingredient here? To figure this out, the researchers basically started taking things away to see what would break it. They asked, what if we just give it the final math equation? Or what if we let it write out its reasoning, but only after it gives the answer? Would that still work? And the results were crystal clear. None of the shortcuts worked. Performance just stayed way down low. So the magic isn't just about giving the model more time to compute or feeding it an equation. The absolutely critical part is that step-by-step natural language reasoning that happens before it gives the final answer. So let's zoom out a bit. What does all of this actually mean for the future of AI? Well, it turns out this simple prompting trick has some really profound implications. All right, let's wrap this up with the key takeaways. First, that lesson from school is true even for AI. Showing your work really matters. Second, this is a big league ability. It's an emergent property that only shows up in massive models. Third, it's an incredibly flexible tool that works for math, common sense, and symbolic logic. And maybe best of all, its real beauty is in its simplicity. You don't need complex training. It's all about how you ask the question. And that leaves us with a really fascinating final thought. We basically just taught an AI to reason better by using a method we use to teach kids in school. So it makes you wonder, what other simple, human-like teaching methods are just waiting out there to unlock even more incredible abilities hidden inside these massive AI models? The answer to that could really shape our future. Thanks for tuning in.